Hi students, I wanted to help you a little bit with your half-life activity. So once you get done with your penny portion and you make your graph for your pennies, now we're going to actually apply that knowledge about the pennies to an actual radioactive real isotope. So the one that you're going to do next is called sodium-24. Remember, a radioactive isotope gives off particles and energy, or radiation, as it's decaying. So we have the parent isotope here, decaying, and the daughter isotope, the stable one, the parent is changing into the stable daughter. Now, once it's a daughter, it will not decay anymore, and it will not turn into anything else. So again, the parent is unstable, giving off radiations like particles and energy, and it slowly but surely decays and turns into the stable daughter isotope. So at 0 half-lives, we have 100 grams of sodium and no grams of daughter, and obviously no hours has passed. So in other words, this parent has not decayed at all. So the number of half-lives, when one half-life has passed, I'm going to put the number 1 right here, and you should also put this in your sheet when you get in your groups. The parent decays by half for each half-life. So in other words, it went from 100 grams to 50 grams. Now, what happened to that other 50 grams that was part of the parent? Well, that now becomes the daughter. And it's taken 15 hours for that to take place. So after a second half-life, the parent decays by half, so half of 50 is 25. That 25 is added to the daughter, so 50 plus 25 equals 75. And 30 hours has passed for that to happen. And it continues from there. And you can do the rest of it on your own. So when you're graphing this data table, remember when you make a graph, you want to use the entire graph. So on the bottom of mine, I am going to put the half-lives. So I had a total of 0, 1, 2, 3, 4, 5 half-lives. So I'm going to write down at the bottom 1, 2, 3, 4, 5 half-lives. And I'm going to label my x-axis. Now, we also had a piece of information where we had the hours passed, or the hours it takes for each half-life. And each half-life took 15 hours. So the first one took 15 hours. In order for 2 lives to pass, it took 30 hours. For 3 lives, it would be 30 plus 15, which would be 45 hours. So we're going to add that on our graph as well. So I'm going to put 15 hours, 30 hours, 45 hours, etc. And you can finish the rest. Now on the side, I have 0 to 100, because when you go back and look, we started with 100 grams of sodium and went down from there. So that's our highest number. So I am going to label this one grams of Na24. Okay? And then I'm going to graph my data. So at the very beginning, At 0 half-lives, I have 100 of the parent, 100 grams of the parent, and no daughter. So let's graph the parent first. So at 0 half-lives, I have 100 grams of the parent. For the first half-life, I have 50 grams. So at 1 half-life, I have 50 grams of the parent, and so on. So I will graph and make the parent red, and when I graph the daughter the same way like you did with your pennies, the daughter will be blue. Don't forget, you need to have a title that tells your reader what your particular graph is about. So again, the x-axis is the half-lives, and not only do I have the half-lives, I also added the hours on there, and you'll finish the rest. And then on the y-axis, I have grams of sodium 24, and I have it distributed 0 to 100. Now notice I used the entire graph to help me make some observations and draw some conclusions eventually.